Hello and welcome to the course on mastering generics with examples. In this video, we are going to be taking a look at what generics are, and then we're gonna basically learn all about generics by example, basically understanding the concepts to um, building out real life examples that you can use within your apps. So first question you might ask, what are generics? And I'm pretty sure, like, you have, if you've been doing iOS development, you have encountered generics one way or the other, because generics are really prominent feature of iOS. They're very advanced, but generics are the most powerful feature, I would say, in iOS and Swift. Generic allow you to generalize and use code in a way that would be impossible otherwise. Generics can be confusing, but once you understand the concept, they will become your most trusted ally in Swift programming. Generics are quite an advanced feature for iOS, and iOS uses generics extensively. Now, this guide is designed to give you a full understanding of generics from the most basic example to their use at the enterprise level app. Alright, so what are the learning objectives of this course? Alright, so we're going to be looking at why do we need generics. Then we're going to go on discussing about what is a placeholder type in generics. We're going to be creating our first generic function. We're going to type constraint generics within the generic definition with protocols. We're going to create custom generic type constraints with protocols. We're going to create associated types and look at what associated types are in generics. We're going to use how we can use generics in protocols, what role generics play in enum, and how to create generic enumerations. We're going to create custom collection data structure using generics to apply all the knowledge that we have gained so far about generics with example. So we're going to build out our own custom collection data structure. We're going to design, basically first discuss how Swift compiler handles generics, so you know the internals about that. And then we're going to make generic we're going to use generic to make something that actually can make it easy for your everyday repeated task. For example, like if you're in this case, we're going to be creating two of the generic functions. There's going to be a network manager routine, basically for calling all the APIs, a generic API, and then a generic table view. So these two routines are gonna give you insight about how you can take your specific code and turn it into generic by refactoring it. Okay, so that is the course objective, and we're gonna take learning step by step. So come on, let's hop on to the next section, and we're gonna basically get started. Alright, so let's talk about the basics first. So Swift is basically a typed language, as we all know, which means that everything that you deal with has a type. Now, if you create a variable of type int, you can't really store a string value down the line. So for example, like, let me go ahead and create a function here. So if you have, like, this sum value, right, and if you have assigned 10 into it, if you look the type for this sum value, you can find that it's actually int type or integer type, right? Now you can print this sum value, and that will be printed. It'll print the integer value, but later on, somewhere down the line, if you try to take this same variable and try to assign a string value into this, you're gonna notice that compiler is gonna throw an error saying like, first of all, cannot assign some value because it's let constant. The other thing that's gonna say is cannot assign value type string to type int, right? Because your type is already defined. Now this is great because this saves you from making mistakes, because you'll always know what some value type will be. It's going to be integer type. There are less of a chances for you to run into issues or make runtime errors because your type is already defined. But there are cases when you need a little bit more flexibility. Now, so imagine if you were to create an add function to add two numbers, right? How would you go about and create that? So let's go ahead and try that. So we're going to create a function add. Okay, it's going to take integer type a and b, and it's going to return an integer type. All right, so you're simply going to say return a plus b, like so. Okay, so this solves the problem. But now if you want to create an add function for double type, what would you do? Well, you would go ahead and create that function with double type. So like that. Okay, now do you see any issue with this? Oh, this is fine for if it were like, just these two functions, but imagine like, you have to do the same thing for all the numeric types, and you want to create basically a function that can take like integer, another function to create double, add CG float and stuff like that. How that code can basically bloat to create like, a huge stack of like, many more number of lines of code that does essentially the same thing. So if you look at this code right here, it actually takes two values, right, and it returns the same type of value, and essentially it does the same thing. Basically it adds two numbers, right? So the logic itself is repeated. Now let's say if this add function, you want to add some additional things. For example, you want to add an offset. You want to add an offset of 10 on B. Now if in order to accommodate this change, I would have to go and make this change in each and every function down the line. Like basically I would have to find all the functions that have this logic and update that because I want to add that offset. That's problematic because that can be error prone, because you may encounter that, like, here in the first example you've added 10 offset, but you forgot to add, or you could not find the other add because it's located in another file or stuff like that, right? So that can be error prone. So how can we fix this? Well, how about any object? So we take any object here, right? And we take any object and any object and basically do the addition on those. Now this would require us to basically add a definition for addition into any object, because addition cannot be applied on any object, right? So that's not the solution that we are looking for, and same goes with any. That's not the solution that you're looking for, because you're actually then typecasting a lot of your types, and that way that will lead to compile time or runtime errors, right? All right. Because like, if you're trying to typecast something that does not have the correct type, then it may lead to your program crashing. So this is where generics come into picture. you can use them to create functions that can work with many different types, built-in type or your own custom type. Now with generics, you write clear and flexible code that can be reused safely, and you avoid duplication of logic. So how would you convert this into a generic add? So let me take this out and create a function add once again. Now this add is going to take, well, let's just name it generic add. Okay, this function is going to take a type. Now we're gonna talk about what this type colon numeric mean in a minute, but essentially what we are trying to say is that take t of type numeric, okay, and then you have all your parameters of type t that returns t, and you simply add a plus b. So this function definition right here does essentially the same thing that we were doing earlier. So let me cut this, and I'm gonna put the definition for to add back in place. Okay, so we have something to compare. So if you look at this function right here is doing essentially the same thing that these two are doing, but the difference is that this function, this generic add function, can take any type that actually conforms to numeric protocol. Okay, so here in this example, instead of giving the parameter a type, we tell the function that take a placeholder type t. Now we can place a condition on that placeholder type t, and that condition can be that it has to be a numeric type. So this is what the condition, this is how you create the condition. Okay, now placeholder type doesn't specify what type t exactly is going to be. Instead, it says that both of the parameters and the return type will be of type t, and the placeholder type t has to conform to numeric protocol. Now if you look at the numeric protocol's definition, you'll find that it actually inherits from other protocols that makes it perfect for numeric operations. So it actually takes additive arithmetic and expressible integer. So it actually makes it perfect for numeric operations like add, right? So how would you go on and use this generic? So let me create a function, use add maybe, and what we're gonna do is we're gonna create two add objects, generic add. Okay, we're gonna make the function call, and this is where we're gonna give it the type. So we're gonna say I want to use 10 and 10. Okay, and I'm gonna store this value in C. Let d is equal to generic add, and I'm gonna say maybe 3.14, 1.25. Okay, now let's try to take a look at the type for C. So if you notice, type for C is integer and type for D is double, and they're exactly same as the values that we are actually passing right here, right? So basically generic has a way of or Swift compiler has a way of knowing, like, what the type we are passing via type inference, and our generic add adopts that type and says t in this case is going to be an integer type, and then it replaces all the other values of t with that integer type. So even return type becomes the integer, because we are actually in our generic add, t is the type that we are returning, right? So that's how you actually make your code generalize. You look at the code that you have, and when you see that you have some repetition of logic or conditions or repeated operation, and you can actually generalize that with some form of placeholder types, and you can even place some conditions, then you create a generic function of that type, right? So this was the simplest example. Let's go ahead and take a look at type constraint in a little bit more detail. All right, so let's talk about type constraints. So in the last example, we looked at type T constraint to numeric. Now this T and numeric part, this colon numeric part, is called type constraint, right? So it's a constraint basically that defines the placeholder type T needs to conform to. And in this case, T needs to conform to numeric protocol. This means that you can't use generic add function with T, like, generic add function with T colon numeric to add two string values or any other types that don't conform to numeric protocol. So if you try out here to add, so let me say E generic add, if I try to add two strings, it's going to be a compile time error, because it's like it says, like the compiler complains here, that generic add requires that string conform to numeric protocol. So this actually prevents us from making those mistakes of not having the correct type. So basically it prevents us from making, like, common mistakes, like two types that are not like addable, but we are still adding those and stuff like that. Okay, so let's take a look at another example. And in this example, we're going to create a function which is going to do a linear search in an array to find an element. Now, if the element is found, the function will return the index for that item, or it will return nil if the item is not found. Okay, so let's go ahead and create a function, linear search. Okay, so when you create a linear search, once again, my recommendation is to always start with with an example, a working typed example, and then convert it to generic. So let's say if you want to take an array of type string, it takes a key of type string and returns the index. Okay, now this is going to basically loop over the item or the array, and it's going to check if the array's current index, ith index that we are looping over, is equal to key. If it is, then we're going to return I. Otherwise, we're going to simply return nil. Okay, so let's take a look at this this example right here. So you have like a string type you're taking, and basically string typed array that you're taking, and you're looking for a string key. Okay, so if you look at the other logic, right, if you were to do the same function or same logic for an integer, the only thing that's going to change is going to be the array. It's going to become array of int, and the key is going to become integer as well, right? Essentially everything else is going to be same because we are still returning the same type and stuff like that. So now what we can do is we can convert this into a generic. So we're going to say you're going to take linear search is going to take type T, okay, and array is going to be type T, key is going to be type T, and it's going to return an integer. All right, now this function, as you can see, will not compile because you see that equal cannot be applied on two T operands. That's the compiler error. So we're using the placeholder type T but we are not telling the compiler enough information what t can be. So in our case right now, t can be anything. Okay, so how would I compiler like know how to compare these two values, like what those comparison criteria are going to be? If they're string, they're fine, like you can just do equal operation on the string or on the integer. But what if it's a custom type, it's like a person object or something? How would you go about and compare two person objects to make sure they're equality, right? So in this case, our code should not compile because t can be anything, and that's exactly what compiler is complaining about. So here's what we will have to give to compiler. We'll have to give to compiler a little bit more information about t using type constraint, and we will use a protocol called Equatable. Now, Equatable protocol declares an equal operator, and whoever basically conforms to that protocol, they have to implement equal operation to tell what that equality looks like. But that's none of our concern. That's actually the object, the object creator or the type creator is gonna have that responsibility. So all we need to do is we're gonna constrain our t type, our placeholder t type, to have that constraint that it has to, well, whoever is this t gonna be, like the type of t is gonna be, that type has to conform to Equatable protocol. Now if you build, you're gonna notice that your error is gone. Let me take this away so our warnings are gone. Okay, so now as you notice, like your error is gone because you know that type t is always going to be conforming to Equatable protocol. So how can you go about and use this linear search function? So let's go ahead and use that. So I'm going to create an array for cars. Okay, and we're going to say if let car is equal to linear search. Okay, and we're going to supply cars here, and we're going to say we are looking for Ford. So if we are able to find Ford, we're going to print that car. Okay, so this is going to print Ford, the index. So 0, 1, 2 is going to print 2. Okay, so the index that it could find for Ford. If we were to look for, like, any other car, then it's not going to be able to find it. Then we're going to get basically nil. So this if let is not going to be it's not going to execute, right, because we are doing the nil check. Okay, anyways, so this linear search function now takes cars, right? So if you look at this type is returning int, right? And linear search definition still says, like, that it has a type t of where t is gonna be equatable. So that's another way of writing your constraint. So instead of doing this, you can do something like this. So show you once again. You can say after your return type, you can say where t colon equatable. That means your t has to conform to Equatable protocol. Okay, so you can use the same function to basically search for an array of integers. or I should say item index actually, because what we are getting is the index car index. Okay. All right. So this actually gives you flexibility. Now you have one function definition for linear search that actually takes a type T, which conforms to equatable, and now whichever type has equatable implemented, they can actually use this linear function to do the linear search without repeating the code definition. There are a few protocols that Swift provides which are commonly seen with generics, like equatable protocol. Equatable protocol, for example, in this case we have used, it's used to tell if the values are equal or not. There's another one called comparable. Now comparable is used to compare if values are greater than equal, greater than each other, less than each other, or equal to each other. And there's a hashable protocol that is used to tell if the values can be hashed or not, or a hash value can be created for that type or not. Custom string convertible protocol, this is used to tell if the values can be represented as string. Numeric protocol, which is used to tell if the values are numbers. Signed numeric, which is similar to numeric, basically used to tell if the values are numbers. Stridable protocol, which is used to tell if the values can be offset and measured like sequence steps or ranges. So each of these protocols have their specific requirements, right? So we have looked at the equatable protocol, and now what we can try is basically create our own custom type. So we're gonna create our own custom person struct, and then we're gonna conform that person struct, make it conform to equatable protocol, and we're gonna see how we can use that custom type with our linear search. Okay, so what I'm going to do is I'm going to create a struct here of type person, and it's going to conform to equatable protocol. Now our person is going to have two properties, name and age. And in order to conform to the equatable protocol, we're going to implement double equal, and it's going to have left hand side, so we're going to say person, and right hand side, which is going to be person, and this returns boolean stating whether they are equal or not. And we're going to say if left hand side dot name is equal to right hand side dot name, and left hand side dot age is equal to right hand side dot age, right? So this is our custom equality operation. This, if these two for this particular for this type, right, the objects that are created of this type, if these things are equal, then we're gonna say the objects are equal, so we're gonna return true. Otherwise we're simply going to return false. That means they're not equal, right? Notice how we are overloading this double equal. This makes person type conform to equatable protocol, and it gives our struct ability to compare two objects for their equality. Now let's go ahead and use this with our linear search. Okay, so I'm going to create a function here. Okay, and we're going to create a person and I'm going to copy this and create a new object, which is going to have the same name, and the age is going to be same. Okay, and we're going to create another object for Bob. Okay, now first let's check if Jim2, so these two are going to be equal. There is no compile time error or anything like that, so it should be good. If you run this, you can actually find these two being compared, returning true and false, right? Okay, but the main thing that we want to try is basically whether we can use these with our linear search or not. So let's go ahead and try that. So we're gonna try to find index for Bob. We're gonna say linear search on people. We're gonna look for Bob right here, right? And we're gonna print all right. So as you can see, if you try to build this, this is basically gonna build without any compile time errors. That means that our custom type that we have created can be used with our linear search because it conforms to Equatable Protocol. Okay, so that's how you create your type constraints. All right, so in the next section, let's talk about a little bit about protocols, because in order for us to create our own type constraint, we need to understand what protocols are. So we're going to discuss about that, and then we're going to create our own type constraint. All right, so let's talk about protocol a bit. So this is just gonna be, it's not gonna be a detailed discussion about protocols, but it's just gonna be like, some things that we need to know so we can proceed with our exploration on generic side. Okay, so so we can basically so we can say, like, you've seen protocol probably, and you might have created protocols of your own. So but again, the definition for the protocol is where protocols specify the blueprint for the function. That means like they provide the declaration, not the definition, and the conforming classes or conforming type needs to basically implement those blueprints. They need to provide the definition of what that type is going to basically, or what those functions are going to do. Okay, so for this example, for to understand the protocols a little bit better, we're going to basically create a simple drivable protocol. So let's go ahead and create a protocol called Drivable. Okay, and this protocol is going to have a function speed. So basically what we are trying to say is all the types that are going to be conforming to this drivable protocol needs to have a speed function. So now let's create some types. So we're going to create some classes that will conform to drivable protocol, and they'll provide some function implementations. Okay, and I'm going to copy this and basically create a truck type, and a tractor type. So as you can see from the example, that protocol only creates the requirement. It does not specify how the requirements are fulfilled. This gives you basically ability to write flexible, reusable, and testable code, which makes your code loosely coupled. Now, with this knowledge of protocol under our belt, let's go ahead and create our own protocol for add. Okay, and we'll call this protocol addable, which we're gonna later on use, or like right after creating our protocol, we're gonna use it with generics. Okay, so we're gonna create our protocol addable. Okay, addable is going to have a function overload for plus operation, which is going to have left hand side of type self. Now notice this is capital S self, that's defining the type. Right hand side self, and it's going to return self. Okay, sorry, function protocol functions cannot have definition. Okay, it's just the blueprint. Okay, now we'll use extensions to integer and double to make them conform to our addable protocol. All right, now when we have these extensions created, we're going to create another add function. We're going to call this one custom add. Okay, and we're going to create our type T. Now this time, instead of conforming to any of the built-in constraint built-in protocols to basically type constrain our type, we're going to use our own protocol to type constraint. So we're going to say whatever T type is going to be, it has to conform to addable protocol. And then just like the other add operation, we simply have to provide the rest of the definition. So let's say a plus b right there. Okay, so if we were to try to use this or create objects for these, I'm gonna basically do it right here. Custom add, I'm gonna supply 4 and 5, and we can print, we can say same thing for add double. Right, as you can see, if you try to build, everything is gonna work just fine, basically creating our custom type constraint. So now as you can see, like how easy it is to create your own constraint using protocol, and all you have to do is basically create your protocol, and then conforming type needs to basically provide the definition for those, and that gives you ability for your generic to create a type constraint. So your generic operation can only basically will only work or compile when those types satisfy that requirement of conforming type or the type constraint. All right, so that's how you can create your own custom, or like your own type constraint. Okay, next let's discuss about protocols in generics, basically how generics are used inside the protocols, what are the associated types, and how do they work with, how do generics work with protocols. Okay, so that's basically what we're going to be discussing next. All right, so let's take a scenario. So let's say that you want to create, or you need a storage box to store something. right? Initially, when you came up with the idea, you wanted to store some books inside the storage. So let's go ahead and create a type. So I'm going to continue on this within this file, and I'm going to create a struct named book. Okay, and we're going to have title for the book. Let's create a let's create a var and author for the book. Okay, now we're going to create a protocol for storage. Now this protocol will have two requirements. Basically, we're gonna for our storage to work, we're gonna have a function to store an item and retrieve an item. So we're gonna say func store item of type book, retrieve by index, and this will return type book. Okay, now we're gonna implement this. Okay, so I have extra O in the book. Okay, all right, awesome. Okay, so we're gonna create a type bookcase class basically to conform to storage, and we're gonna use that to store our books. Okay, so we're gonna create a class bookcase that'll conform to storage, and create an array of books. Okay, as you notice, we are getting this issue of stubbing out all the functions, so I'm gonna do that, and let me go ahead and cut this and paste it right here. Okay, so the store is gonna basically simply take the book and append it to the books array. Okay, and retrieve is simply going to return a book from the index. So index is given, we're gonna return the book. All right, now let's imagine that we need to store something else in the bookcase, maybe video game discs. Now, how can we go about reusing these using bookcase to have items of type video game disk? Can we create another class conforming to storage protocol, and then basically do the same operation? So essentially that's gonna perform the same operations, like exact same what bookcase is doing, except a different name. So let's go ahead and take a look and see, like, the repetition that we are sensing here. Okay, so I'm going to create a struct video game, the type that we want to store. Gonna have title and publisher. Okay, then we're gonna create a class. We'll call it video case for storage. That's gonna conform to storage protocol, and we are going to simply take the same thing and I'm going to simply replace the types. Okay, now let's make sure that actually not conform to storage. Well, yes, of course, because our storage type expects a book, right? Um, so as you can see, like, we ran into this issue. Now we'd have to actually create a type, a protocol that is going to have to take games as a type. So store games as a type and retrieve game as a type, right? So you see, like, how many things that we'd have to basically repeat. Okay, so how can we use generics to solve this? So let me go ahead and comment all of this out. Okay, and we're gonna recreate our storage with a different setting. So we can use something called associated type inside our protocol and use that as the type. So when a class will conform to the protocol, then it'll provide that type, that associated generic type, which is going to define what that item is gonna be. Okay, so we're gonna take the exact same definition right here. So I'm gonna copy that, and instead of saying the book, right, I'm gonna create an associated type item. It's gonna be some item. Okay, capital I, item. But we're gonna call store, we're gonna say store item. Okay, and return an item. All right, now once again, we don't know what that item is gonna be, so items definition or the type is gonna be determined at the conformance level. Whoever is going to conform to this protocol, they are going to provide the definition. Now with this change, our protocol is now generic. Now it can be used with any kind of storage. You can store your video games, your boxes, your books and stuff like that, right? So we can take this further and create a box class that is going to be a generic box, and we're going to use that generic box to basically conform to the storage protocol. Now when that generic box's type, placeholder type, is resolved to a concrete type, that type is going to become the type of associated type. Okay, so there are a lot of types here. Okay, let's go ahead and type it out and we'll see. So we're going to create a class called box, which is going to have item. Okay, it's going to take item, storage. Okay, and this item can be T. Okay, and we're going to basically say, okay, conform to this. So we can actually easily provide this. So we're going to say items. All right, so now if you notice, your compiler is complaining that box does not conform to storage. Now there are two ways to solve this. Reason I actually typed T, so we know that this is actually going to be the placeholder type, right? Now this type can be item, so it can directly associate its type, right? And here we'd have to actually provide the type as item as well. So now the associated values are resolved. Now in case you don't want to do that and you want to understand basically how this type association works, you simply have to provide a type alias. Okay, so if you try to resolve this, it's gonna ask for type alias like it asked earlier. I didn't fill it out, but now what we are saying is we are creating that relationship between the placeholder type and the associated type within the protocol, right? So we are saying that type alias T, the item is going to be of type T, so exact same type as the T is going to be. Okay, so just want to show you, like, how that association goes for the type between type alias and the associated type. Okay, for simplicity, let's go ahead and conform to item. Okay, and this item is going to be associated, or create the array of items. Okay, now when you have your box, you can create box of anything. So for example, if you try to create, like, let's create a function use storage. Okay, let's create a box to store books. So our book box. Box of type book, right? And you can simply say store. And as you notice, the items type now is not item, it's actually book, because we are resolving that here. We are saying we need a box for type book. Okay, so we are simply gonna give a book, so we can say title. And I'm gonna copy and paste the same thing and change the title. Okay, so those two are going to be basically those two operations are going to store book, and you can basically print by retrieving the book from the storage, right? Okay, so you can take this same. Okay, let me scroll back down, and let me take this whole thing and create a video game box. So I'm gonna say games box, and we'll create a type here. Let's create struct. Okay, and we're gonna say this is gonna be of type game. Okay, so now our box is of type game. That means it can store basically instances for game object. So from this example you can see that you were able to reuse the box class itself for different types. Okay, and basically this definition right here for the class box also gives you an ability to subclass stuff. So let's say if you want to create a gift box, right? And that gift box can have its own basically its own type, which then can be associated to your box type. So for example, class gift box, can have a function, maybe a wrap function. So we want to gift wrap these. So here our function is simply going to return saying gift wrap the box, right? So this becomes a gift box. Now you can use this subclass, right? So you can basically create a toy struct to store a toy, and we're gonna simply name that toy, and we're gonna create toy box. It's gonna be a gift box of type toy. And if you look at your toy box, you have all the operations that you had inside your your box, right? So you could store basically a toy. So we are simply gonna say Woody and Buzz Lightyear. Okay, and we also get the operation that our subclass provides. For example, wrap. So basically you put those two toys and inside your box, and you gift wrap it. So as you can see that like your subclass can have its own definitions and still can be generic. So our gift box inherited from box, which was a generic type, which provided the conformance for storage box, which was generic. So you were able to create these generic types just by providing a placeholder type that could be resolved later on when you're trying to use them. So far we have seen classes, structs, protocols, how they work with generics, but enums are another important type in Swift, and they also work really well with generics. So in next section we're gonna see how enumeration work with generics. Okay, so that's gonna be the topic next. All right, so like I mentioned, enums or enumerations work really well with generics as well, just like any other type. And for this, let's take another example. So imagine that we need to store location, and our location enum only provide two options, basically location by address and location by coordinates. So let's go ahead and create that. So I'm gonna continue on the same file. Once again, create enum location. It's going to be case for address. That will take type string. And coordinate, that will take a double type, or two double parameters, right? So we're going to use this enum. All right. So, and we can actually print these location 1 and location 2. Okay, so I'm gonna just try to build, and build succeeds. So everything works as usual. You've created enums a bunch of times, so it's the same thing, right? Okay, so if you notice that our location type has a defined type. But what if you want to provide a location for basically an address, right? So you want to provide an address object instead of passing an address string to your location. You have two options. You either conform to string convertible protocol for your address object, create an address object, and then it'll conform to string convertible, and then whenever somebody try to, like, get the string version out, they can actually get the string description out of the address object, and it'll construct the address and give it to you. That sounds a lot of work. Okay. Or basically in this case it sounds a lot of work. It's a good thing, like, if you provide a custom string convertible protocol, but that is not the issue for today. What we're talking today is how can we use generics with enumerations, right? So in our scenario, what we want to do is we want to make a generic enumeration for location that can take any type, and then basically by providing a type, it can actually by taking a type placeholder, it can basically take any of the type that we create for our purpose. So how would you go about to that? So let's go ahead and try this out. So we're going to create another enum, okay, and we're going to call this gen location, generic location, right? Going to give it a type t. Now our address is going to be taking t, and our coordinate is going to be taking type t as well. So I'm going to show you two different types that it can take, right? So now let's go ahead and use this. Generic location. Okay, so we're going to create a struct for address. Now this address is going to have some properties. Okay, so these are the properties for address. Now let's create our location. So location 1, generic location, let's use that, dot address, and we're gonna say this is going to be an address that we just created. Okay, so we're gonna simply say all right. So this becomes our generic location enum that takes a type address. Now similarly, you can create another location. So you can create location 2. You can say generic location dot coordinate this time. Okay, and in order to use with the coordinate, we're going to create a new struct for the type. We're going to say this type is called coordinate. It's going to have lat and long, right? So this coordinate takes those two values. So I'm going to simply copy these two right here. Okay. All right. So as you can see that we have made our location enum pretty useful by providing this generic type. So your location enumeration now basically does not have to take the specific type, but it can be generic as well, and it can conform to a type that you actually define using type placeholder. Okay. All right, so Swift basically uses this pattern in many places in its standard library for generic enumerations. For example, optionals is one of the biggest, like, most used example, where you have optional, and optional is your generic enumeration. It basically adopts to the type that you create optional for. Now, you must have used result type. Now, result type is another great example of generic enumeration. Okay, so that was all about the enumerations and generic enumerations. Next, let's go ahead and talk about or basically create our own collection data structure using generic. So once again, we're gonna take a specific approach. So we're gonna create a collection type of a specific type, and then we're gonna refactor that. We're gonna basically refactor it to create a generic version out of it. Okay, so that's what's coming up next. All right, so if you have used arrays in dictionaries, you might know, like, there are several other types of collection types that Swift has. Now, this might not be surprising to learn that these types are created as generic types. So arrays, dictionaries, all these are generic types. That's why whenever you create them, you specify, let's say you create an array of integer that can only take an int type, then you can use the similar definition for creating like a string array. And string array is pretty much similar. It's just it basically restricts the type to be included as type a string, right? So you can only store string type of values inside that array. So so that's actually, like, how iOS sort of uses, SDK itself uses generics as at an extensive level. So what we're going to do in this video, we are going to be basically creating our own collection type, and we're going to be creating something called a stack. Okay, so what we can do is you can create a new file here, and I'm going to create a stack example maybe, and we are simply going to create a struct. Okay, so we'll start with a simple stack, and the thing that I want to point out here is that you don't start with generic type right away. The general rule of thumb is to find out the place where there is a repetition of logic or a concept that can be generalized, then only you should use generics. So goal should always be to start simple and refactor as needed. So we're gonna follow the same approach. Okay, just to give you a stack refresher, stack is a data structure that stores items in a last in first out order. So stack is basically just like a deck of cards sitting on the table. Now you can take this, you can't take second card from top out, right, without taking the top card, so, or without moving the top card. So if you want to take the second card, you have to move your first card, the topmost card, first, right? So stack works similarly. Now if you put a card on the top of another card, you always put the cards on the top. So last card that goes into the stack is the first card that is gonna come out. It's like stack of dishes and stuff like that, right? So basically that's what stack is, and similar to the concept of, like, playing cards or a deck of card, we have data structure called stack that actually has items going in, and the last item that goes in to the collection is the first item because it's the topmost item. That's the item that will come out. So with this sort of, like, refresher, or, like, example in place, let's take an example of building a string stack that'll basically take string type and stack them up, and then basically take the topmost string out, so one by one. Okay, so we're going to create that. So let's go ahead and create a struct stack. Okay, and we're gonna create private var items. So we're gonna use array bagged stack, and this is going to be of type string. Okay, now there are a few operations that you can do on stack. So you can put an item inside the stack. So we're gonna say mutating func put item of type string into the stack, right? And we're gonna say items dot, instead of append, we're gonna insert, because we want to insert at the top. So whenever you add an item on the stack, it has to be on the top, so you add at the top. So you're gonna say item at index 0. Okay, when you're taking the item out, you take the first item, the topmost item, out. So you're gonna say create a function called mutating func pop. The operation itself is called pop. So we're gonna take that and it'll return optional string, and we are simply going to say items.count. If it's greater than 0, then we're gonna say items.remove first. Of course, question mark items dot remove first, otherwise return nil. Okay, and other than these operations, your stack also has a peek operation. Just like if you don't want to, like, move the topmost card in your deck of card, you just want to look at what the top card is, you just take a look, you pick it up, take a look at what the card is, and then put it back on in the stack. Basically that operation is called peek, so we can implement that function as well. Peek, it's going to return optional string, and this is going to be simply return items dot first if there's any. Okay, all right, so this is our stack, right? If you were to use this, right, I'm gonna use it like this. So you will create a stack, right, and we're gonna start putting items into the stack. So okay, and we're gonna print, so we're gonna use peek, and let's take out an item and iterate over our stack. So we're gonna say item stack dot pop, while item is not equal to nil. That means we still have items inside our stack. We're gonna simply print item, and then we're gonna take our item and assign next item using st.pop. Okay, so let's take a look at what the all right. Okay, and what I'm going to do is I'm going to use this viewDid load and call this stack example. Stack example is basically this example that's going to create our stack, put the items, and then pop the items back. Okay, so let me go ahead and run this. And what we should get is basically the stack being printed. But if you notice, last item that we put in was exclamation. So when you did peek, you got the exclamation out. Okay, I mean not out, but you looked at it. The topmost item is exclamation. Then when you started popping item out, you had exclamation first, that was removed. Then next item, the second last item that was put in was world, so world got printed, and the last item that was printed after that was hello, so hello was printed. So basically your last item that was put in came out first. That is the basically stack, right? It's the nature of the data structure itself. That's how it basically operates. Now another application for a stack is basically an undo manager, where when you press your command Z or control Z or any undo operation that you do, it basically reverses the last operation that you did, because that's the topmost element inside your undo stack. Okay, so now when we have this example in place, now let's take this stack and make it a generic version. Make a generic version of the stack. So what can we do? So here we can refactor this stack right here, and we will say this stack takes type placeholder t, right? And we want to store t. Okay, and items is going to be of type t. Whenever we insert an item, that needs to be t as well, okay, for the same type. When we are going to return an item, that item return type is going to be t. Okay, and the first item during the peek, when we do the peek operation, is going to be of type t as well. Now, if you notice that our stack is complaining that generic type t could not be inferred, so we're gonna say, okay, this time we are providing that t type is going to be of type string. So if I go ahead and run this example, it should basically work as is. Okay, now let's change this and let's make it int. So this is going to be now a stack of integer. And I'm gonna put 1, 2, and 3 here. Okay, and let's go ahead and run this. If you notice, there is not much that we needed to change, and our same definition of the stack was basically used to create an integer based stack. So that is the flexibility that you get when you create your functions generically, right? When you have like a function that is generically defined, then your type it defines what that generic function holds and what it operates on. All right, so let's talk about internals of generic. How you must be thinking how Swift generics work internally, meaning how does the compiler know which type function conform to and which is not the case of the placeholder type, right? So, well, basically Swift compiler takes a simplest approach to handle this, to determine what that t is going to be and what those definitions for the functions are going to look like. What it does basically, it takes your generic code and creates a specialized version of code at the compile time. Okay, that specialized code, for example, looks like something like this. So if you were to go back to our example of generic add right here, this guy right here, right? So if when compiler will look at this type, it'll basically see that it's being used for two types, integer and double. So what's going to do is it's going to create two generic integer types. So it's going to basically create, so let me put a comment here, and it's going to create a function. So let's take this definition right here. So these two functions are going to be created. So the t is not going to be there, and your types are going to be int and int replaced, and for double it's going to be same. So all the t's are going to be replaced by that concrete type. So it basically creates these functions literally inside the code. Now this process is called monomorphization. So it's like polymorphic nature. So basically it turns your polymorphic code into concrete function definitions, and it actually keeps that definition instead of keeping it generic. Now this does not mean that Swift is going to generate a lot of code, right? Swift compilers is smart enough to basically prevent large binaries by producing generic add concrete function at the lowest level possible. So during the runtime, Swift uses value witness table to keep the metadata about function and passes the corresponding metadata to the lower level representation of generic add function whenever the function is needed. Okay. With all that, you now understand how generics actually work, both at the internal level and both from the usage perspective, how you can take a simple any example, any logic, and convert it into a generic version of that type. Now let's talk about enterprise level of examples in generic. So these are like, simple functions, add and remove. We looked at like slightly complex example with stacks, where we actually created our data structure. That data structure was initially non-generic, then we converted it into, refactored it to basically make it generic. But what else can we do with it? Well, there are a lot of things, as it turned out, like that he can do, and we're gonna look at two specific examples that you can use at your enterprise level applications. So first one is gonna be a network manager. So we'll start with a network manager which will download data from an API, and it'll convert that API into string and whatever the data is being downloaded. Now once we have our network manager working, we will take that same function and make a generic version out of it. So basically that generic version of network manager will take any type that you just have to call the API for, and it'll return you that typed response back. Okay, so that's going to be first example that we're going to look at. Second example we're going to look at, where we're going to take our table view, and we'll try to first simplify how table views can be created with ease. And once we have created a table view working with a simple string based example, we're going to convert that table view into a generic table view that can work with a type that is given by you using a type placeholder. Okay, so that's what we're going to be doing in next section. Okay, so I'll see you guys in next section. All right, so what we're going to be doing is we're going to be designing our network manager layer, and we're going to basically get the data from this API. It's the Star Wars API, so the URL is swappy, so Star Wars API .dev, and if you go there, you're gonna basically so if you go to the base URL, Star Wars API, you're gonna get to the point where you can search for people. So you can, if you know the people, you can get that information, or you can look at the documentation, and the documentation is pretty good. The link that we're gonna, or the URL that we're gonna use is gonna be for searching. So we're gonna basically search for some keyword. So let me go back there. So you're gonna search for people with keyword sky. Okay, so this is gonna basically give us Luke Skywalker, Anakin Skywalker and stuff. So you're gonna get that data, and we'll try to download this data using our new network manager. Okay, so that's what we are going to be doing. All right, so let's go ahead and go into Xcode, and what we're gonna do basically is yeah, okay, all right, so let's go ahead and design our new network manager. So I'm going to create a new group, call it API managers, or we'll call it managers. Okay, and we're going to create two. Like I said, I want to leave both examples in place, so we're going to create one that is going to be specific. So we're going to say this one is called network manager. Okay, and we're going to design this one first, and then we're going to create a generic version out from this one. Okay, so for the network manager, we're going to first create an enum. Network error. Okay, we're going to have cases for failed when we receive an error, which is going to be error type. We're going to have case for invalid response. And we're going to have a case for empty data. Okay, next we're going to create our class network manager. And this class is going to have one function called fetch, which is going to take a URL and a completion escaping type, which will return a result of data and network error. Okay, and this function is not going to return anything. Okay, so let's see, what did we, okay, we have to put this in place, so I'll go ahead and format the code. All right, so first we're gonna guard against, so guard against errors. So if error is nil, then proceed, otherwise call completion with failure, and we're gonna pass basically our error object. And return. Okay, all right. So, um, sorry, my bad. Okay, so we need to first create our URL session so we can get some data in response. Okay. Uh, okay. So data task. Okay, data task. The one that we're gonna choose is gonna be the one that takes URL and a completion handler. Data response and error. Okay. Now our guard statement. If we encounter any error, we're gonna guard against that, so we can send the correct response. So we're gonna say, if there is a failure, if there is an error, send failure with error. Okay, let's okay, let's send failed network managers, sorry, network errors case failed, and we're gonna pass it as error. Okay, perfect. Then we're gonna have another guard, let HTTP response as HTTP URL response, and we're gonna check HTTP response as status code, and we're gonna say if this status code is equal to 200, then we're gonna call our completion. I mean, if it's not 200, then we're gonna call our completion with a failure invalid response as the network error type, and we're gonna supply our response here. So caller gets the response so they can basically analyze what kind of data is being sent. Okay, those are failure cases. Now we need one more. We need to get the data. So we're gonna say, let's try to find data. So unwrap data, and if we get it, that's great. If not, then we're gonna send empty data in the completion and return from here. Okay, so by this point we are assured that like, you know, that this response has something. So we're gonna say, now we can send success with data in it. Okay, that's called resume on our service, and our network manager is ready to be used. Okay, so what we can do is we can go here, and I'm gonna basically remove this or comment this stack example, so we can actually call our network manager. Okay, so let's first call the network manager just like that to see if we get access to any kind of data. Okay, so we're gonna say network manager dot fetch with URL, and I'm gonna paste the URL from the search. So let me copy the search URL, and we're gonna create our URL object with string, and this string is going to have this sky search in it. Now for the completion, we're gonna get results. Okay, so what we're going to do with these results is basically we are simply going to switch on the results and just say case dot failure. We're going to get the error, network error type. So we're going to say just print error. For the success case, we're going to get data. So let's try to get JSON out of this data. So I'm going to say try JSON decoder dot decode. Okay, so we need to decode something, right? Now that decoding is something that should be the response. So decoding class should be what response send us. So in order to use decodable, we need some sort of object that we can decode. So if you look at the response right here, we have response coming in inside a JSON which has key value, right? And then it has results which has the actual results that we are interested in. So we're gonna create an envelope object, and we're gonna unwrap that, and we're gonna unwrap results from there. So let's go ahead and create a couple of classes. So I'm gonna create them. Let's create a new group, models. Okay, and inside this models, we're gonna create our file. So first one is going to be person, because we are interested in person. So I'm gonna create that. Okay, and there's gonna be a struct called person, okay, which is going to represent this result right here, this section. And we are interested in name, gender, homeworld, and films. Okay, so these are a few values that we're gonna get. So let's go ahead and type those. So all right, and for films, basically this is an array of string, right? So that's why we have array of string. Okay, now this is all coming inside this another response body. So basically, sorry, it's the same response body but another key value. So the key for this one is results. So what we can do is we can create an envelope object. So we can say struct Star Wars API envelope. This is going to be codable. Results is gonna be array of person. So results is the same key name that we are getting here, right? And we're gonna make sure this is also codable. Okay, now there's one more thing that we're gonna do. So let's create an object for that too. So if you look at these films, right, films has these other objects, like, you know, films is a different type. So we're gonna basically use this films object as well to fetch data. So let's go ahead and create its model as well. So I'm gonna actually so let's do this. Let's create a new file, and I'm gonna call this envelope. And I just realized I misspelled this. Okay. All right. Cool. So so basically it's gonna have its own, and then we're gonna create a film. So film object, and this film object is going to have title, or film type. Actually, it's gonna have title, opening curl, and director. These three things that we're gonna get. So we're gonna create a struct film Okay, so these three things that we are interested in. Make sure. Yeah. Okay. Cool. So we're gonna go back to our view controller and this decodable protocol type, right? So this decodable protocol type, we are going to actually ask this to decode the envelope. So we're gonna say this is going to be Star Wars API envelope.self, okay, from data that we are receiving. So whichever data we are receiving, we are actually gonna pass that. And in case of success, this data is going to be some data because we have checked for all the other cases. Now we're simply going to print this JSON. Otherwise, we're going to say no data, which is not going to be the case. All right. So, okay. So what we're going to do is now let's go ahead and run this. And we should see some response right here. So there we go. We are seeing this Luke Skywalker and Anakin Skywalker and detail about them. So there are 3 Skywalkers that we are receiving right here, and that means that our network manager is working fine. Okay, so what we're going to do is basically we are going to convert this into a generic version of network manager. So let's go ahead and create that. All right, so one thing you notice basically in our current network manager that it gives you data back, which is kind of generic because I mean it's not generic, but it doesn't specify any type, so it's actually ready to be reused. But I think that it would be awesome if instead of getting data, we get a type, right? We get, like, the JSON converted and we get the JSON response back. So we don't have to worry about all this decoding stuff, right? Okay, so for that, what we're going to do is we're going to create a generic version of network manager. So I'm going to call this generic network manager. Okay, and what I'm going to do is I'm going to copy this guy, only the section, because we're going to reuse our network error. That's not going to change. So we're going to say this called generic network manager. Okay, so what are the things that we can change? So a few of the things that we need basically is we need this data to be some type that we can ask our user to supply, and then we can use that. And once we get that type, we would be able to basically perform this JSON decoding operation right here, right? Okay, so what we can do is we can make our generic network manager basically take type T, type placeholder T, which is gonna be which has to be constrained to codable. So it's gonna say type T, supply me type T, but it has to conform to codable protocol. Now this gives us flexibility that we can return T type result. Now as soon as you change that, the optional basically, as soon as you change that, you're gonna see that our completion for success is throwing an error, which is correct. So I'm gonna remove this for now, and what I'm gonna do is I'm gonna simply take that JSON conversion that we were doing in the other in the view controller. I'm going to move it right here. So I'm going to say JSON decoder dot decode and decode t dot self. Okay, because that type is conforming to codable, that means we would be able to get that type and get supply to decoder to basically decode the results. And we're gonna call completion with success. And if you notice that the success expects something called decodable and encodable, which essentially is the same thing as codable, because codable protocol inherits from decodable or and encodable. Okay, so we're gonna simply pass our JSON right here. So if you try to build this, your build should still succeed. Okay, and now what this gives us basically a flexibility is to search or get the data in a generic way. Okay, so let's go back to our view controller. Okay, and what I'm gonna do is I'm gonna comment this guy out, and we're gonna call generic network manager. Okay, now this generic network manager is going to have a type that it needs to takes. So we're gonna say it's gonna be Star Wars API envelope. Okay, we're gonna create its object and call fetch function on this. Okay, fetch is gonna expect the same URL, so I'm gonna just copy and paste that one. Copy paste this guy, and for your case, like, you can even simplify this to use URL component, create another class to basically extract this out. But I'm trying to focus on basically the conversion of a network manager into a generic network manager, so that's why I'm not going into too much detail about that. Okay, so we get the results and we apply a switch statement on results. Okay, now in case of failure, we get the error, right? And we print the error. In case of success, we get Star Wars API. So I'm gonna print Star Wars API, or I'm gonna say no data. Okay, all right, so let's go ahead and run this, and then we're gonna do another test. So as you can see, our response is basically returning the same results, but this time we don't have to do this JSON decoding and stuff like that. So our code is a little bit simplified. It's a lot simplified actually. Okay, now what we're going to do is we're going to create another function. So I'm going to create a function down here, and this function is going to call films basically for first film for this person. So we're going to see how we can use our generic network manager to fetch a different kind of result, right? So I'm going to create get films for person or get film, actually, because we are only returning the first film. And we're going to say guard let person is person, otherwise return. Okay, and then we're gonna call our generic network manager. This time we're gonna initialize or give the type as film that we created. Create an object, call fetch for URL with string, and string that we're gonna construct is gonna come from person dot films. Okay, so there's a name conflict in person because I think we have created a person object somewhere right here. Okay, so I'm gonna name this one person 1. All right, there we go. Person dot films 0th index. Okay, so that'll give us the first film for that person. So I'm gonna say we get the results, and we are simply going to put a switch statement on the result, and we're gonna say case for failure is gonna have error. It's gonna print error. Case for success will get us film. We're gonna print the film. Otherwise, we're gonna simply say no data. Okay. All right. So when we get the results, we're gonna simply say self dot get films for Star Wars API dot results at 0 to text. So for the first person, let's get the film data, and let's go ahead and make a call to that and get that information. So you're gonna notice that what we're gonna get is a Star Wars envelope result, and then we're gonna get a film response as well. Okay, so basically what this is telling us that our generic network model is taking the type right here and right here, and it's converting that data successfully into a typed object and returning the typed object instead of returning data. So this proves that our generic network manager is working for both different cases as long as they both conform to Codable protocol, which they are. Okay, so this was the generic network manager that I was talking about, and you notice how we started with a simple example where we did not need a generic version, and then we simply refactored by looking at the things that we need that is going to be common for all the other classes. We determine what the type constraint is going to be. In this case, it has to be codable, and then we actually performed our operation according to that to produce our results. Okay, so that's how generics should be designed. Okay, so next up, we're gonna do the same thing for a table view. So first, I'll show you how you can create a table view inside another, basically a subclass of table view. So you can wrap all the functionality of table view inside a class, and then we're gonna load our API responses into that table view, and then we're gonna convert that table view into a generic table view. Okay, so that's coming up next. All right, so now when we have our data basically being downloaded from the API, I think next step is to go ahead and design our table view. So what we're going to do is we're going to create our table view in such a way where we can contain the logic for table view, like data source and delegate, inside another class. So whenever we need to use it, all we need to do is basically drop that or create that as a property, and then constrain it, and we should be done with that. Okay, so that's the approach that we're going to take first. So we're going to create a table view that is going to take a string and display the string items as a row. Okay, so let's go ahead and create that, and then we're gonna convert that into a generic version. Okay, so I guess what we're gonna do is we're gonna create a new group, and here we're gonna call this one maybe table views. Okay, and I'm going to create a new file, and this file is going to be called a regular table view. Reason I'm naming this one regular table view because I want to create a generic version out of it, but first we're gonna create a regular version which actually is gonna look like any other table view. Okay, so you like it? and we're going to create a final class. Regular table view. This is going to inherit from UI table view, and it's also going to conform to UI table view delegate and UI table view data source protocols. Okay, now there are a few things that we're going to need. First of all, our table view needs some items. So what we can do is we can create items array of string, like I mentioned, and we can create this private. Okay, and we can create private config. Basically, this is a way for us to config a cell. So this is going to be a closure that we can call and config a cell. So this closure is going to take string and UI table view cell. Okay, and this closure is going to return void. Another private variable we're going to create. So private var selection handler or select handler, whatever you want to call it, selection handler. This is going to basically this is going to be a closure as well, which is going to provide the string. So this is basically going to be our way of telling the view controller that something was selected, so you can take action on those, whether you want to launch a new view controller or you want to print that statement or anything that you want to do, any action that you want to do. We want to call this closure, so this selection can be executed at the view controller level. Okay, now we're going to create our initializer. This initializer is going to take items, an array of string, config, escaping closure, and selection handler, which is going to be another escaping closure as well. Okay, so this is going to be our initializer, and we're going to set items to items, config to config, selection handler to selection handler. Okay, now we're gonna initialize our super class, the UI table view class, and we're gonna say the frame is gonna be 0. Okay, and the table view style is gonna be plain. Then we're gonna set ourselves for delegate and data source. We're also gonna register a cell class, and we're gonna say this is gonna be UI table view cell dot self, and reuse identifier. We're gonna just create it as cell. So let's create a private let use ID, so we can use that instead of string. We use ID. Okay, and we also gonna change the translate auto resizing mask into constraints, because we want to constrain our table view using auto layout. Okay, now I'm gonna just get the fix this error with the suggestion for required init. We are not going to be creating this table view using storyboard. If you were to create that using storyboard, then you have to actually populate this init as well. Okay, all right, so in order for us to conform to these protocols, let's go ahead and fix this protocol issue with the suggestion. So basically, the data source, table view data source, requires two functions. There's a table view number of rows in section, and cell for row at index path. So what you can do is for number of rows in section, we're gonna return items.count. And for cell for row at index path, we're gonna create a cell. We're gonna dequeue reuse identifier for we're gonna dequeue reusable cell with identifier. So identifier is gonna be our reuse ID, and index path is gonna be our index path, and we're gonna return the cell. Also, we're gonna call our config to basically provide the items at the index path dot row. So we're gonna call that closure, and we're gonna pass the cell. So what we are doing here is we are passing config, we're calling config closure, and we are passing the current item in the row and the cell. So the caller can set these values. Okay, and we're going to see how to use this in a minute. Now for the selection handler, we're going to do something very simple. So we're going to say did select row at, and here we're going to simply call selection handler and supply the item at index path like that. Okay, we also need a way to reload this table, right? So what we can do is we can create an extension, and inside this extension we can create a reload function that takes data. Internally we are gonna call this items of string type, and we're gonna say self.items is equal to items, and dispatch queue.main. So we're gonna call table views reload data function. Okay, so we're gonna set the new items and call the reload data. Okay, all right, so with this our table view is ready to be used. So what we can do is we're gonna go to our view controller, and what we can do is we can create we can create a new lazy property. So let's create a lazy private lazy var table view like that. And instead of creating UI table view, we're gonna create regular table view, because that is the class that we have created. So we wanna make sure we use that, and we're gonna say regular table view. So regular table view is basically gonna need some of the things to initialize. Like it's gonna need items, config, selection handler, and stuff like that, right? But we don't have any items to show. So what we can do is we can create a people array, an empty array of person. So I believe our data is called person. So let's see, we are calling sky with the generic. Okay, and we are getting a person object. Let me see. Yeah, so we're getting a person object. So what we can do is we can simply create a person array, empty array, and upon successful network call, we're gonna say self dot person people is equal to swappy or Star Wars API dot results. Okay, and what we can do is we can simply say if let people is equal to Star Wars API dot results, then self dot people is equal to people. Okay, so we're gonna set our results here, and this is gonna basically populate this guy right here. Now we have our items ready, so what we can do is we can take people, we can map on each item, and we're gonna say $0 of first property dot name. So we want to display the name here. Okay, so you're gonna get the name, print that. For the config, this is where we are actually getting a cell. So we are getting the item at the cell, the current item at the row index, and the cell itself. So we're gonna simply say cell dot text label dot text is equal to name. So this gives us basically flexibility as what we want to do with the cell. We are letting our view controller basically, if you want to provide a custom format, or your view controller want to collect different styling and stuff like that, you can actually collect that at the view controller level, and you have the view, and you can basically combine those two together. So that's why this technique actually works better than creating your UI table view right here in the view controller. And what we're going to do for the selection handler is we're going to say selected name, and we're going to simply print that selected name. Okay, and at the end, so we want to make sure that we return our view. Okay, so this is basically going to create our table view. So that's all the code that's needed to basically create your table view, right? Now what we can do is inside the view.load, right, we can simply I'm going to make some room here, and we are going to let me refactor this, and let me take this out and put it in a function get. Okay, that way we can make this call right here. Okay, and then we're gonna add our table view inside our view. Okay, and then let's constrain this. So layout constraint dot activate, and we're gonna pin our table view across and to cover the entire screen. So we're gonna say table view dot leading. I'm going to copy that, paste it 4 times. Okay, so let me fix all of these. Okay, so bottom, top, trailing, and leading. Awesome. Okay, so our table view is set, and we are making all the calls, and that's all needed. So let's go ahead and run this, and hopefully we will get our data back. Now if you notice, we get our table view, but our data is not loaded. Why is that? Usually what happens, like whenever you're loading the data, you want to call your table views, you want to reload your table view, right? So what we're going to do here on the network call, whenever we are setting this people object, we're going to simply say self.tableview.reload. So we're going to call our reload function, and we're going to provide self.people.map. And reason we are mapping this to name, because right now our table view only takes a string type. Items is basically items is a string type. So we're gonna see how we can generalize that, but let's make sure this works properly before we actually do that. So there we go. So you have your table views created, and your cells are created, and all the names are being displayed properly. Now this table view is very limited in use, because it only takes a string. There's less of formatting and stuff that you can do with this table view. So what can you do? You cannot provide any kind of cell and stuff like that. So it's like it's gonna be like, you know, pretty difficult to create an app with this. So what we're gonna do next is basically we are going to create a generic version of this table view, but this is actually a good place to start because this gives us a reference point, and this shows us a need that we need to basically convert this into a generic so we can use this table view with any other data source and any other type as well. Okay, so that's what we're gonna do next. Next we're gonna basically convert this into a generic table view. Okay. All right, so now when we have created our table view, a custom table view that wraps all the table view logic inside a class, we have already hit the limitation of this table view because it only takes strings, right? So now we're gonna extend this to create a generic version out of it. So let's go ahead and create a new file, and I'm gonna call this generic table view. Right, and reason I'm creating this as a new file, so you can keep the other file as a reference. So that's why I'm gonna basically what I'm gonna do is I'm gonna copy this and paste it. Okay, so you already have UIKit copied. That's awesome. Okay, so now we're gonna name this generic table view. Okay, and we also want to make sure that our extension is generic table view as well. Okay, so now let's start to identify what are the things that we're going to need to convert into generic. So we're going to need two things. One thing we definitely know that string is not going to work for us. Okay, so let's create our placeholder, and we're going to say we are going to expect an item, right? A placeholder item. Okay, but we don't know what that item is going to be, so it can be any kind of object that can basically work for us, and we're going to create that item as a items collection. Okay, so we're going to basically change wherever we are using string, we're going to change that to item. Okay, so item, and the selection handler also takes that. Okay, right, there we go. Okay, so last thing that we're gonna change is gonna be this one. Okay, so hopefully if we build, we should be able to build. That's awesome. Okay, so now our table view is able to basically take that item generically, right? So this item can be any type. Okay, now one more limitation that we hit was UI table view cell, because there are, like, you know, only few types of cell that you can provide, but we want to basically provide a custom cell, right? So we're gonna take that as an argument for generic placeholder as well, but this time we're gonna constrain this to say cell can be anything that conforms to, that is a type of UI table view cell. Okay, so as you can see, like, you know, table view cell itself, if you look at the definition of it, it's a class, right? So what this tells us is basically for the constraint, for the type constraint, you can not only have a protocol, but you can also have a class, right? So any type that actually that it can constrain to can provide the compiler a definition that this is the type it's gonna be, and keep this type constraint to uh, these these values, and what this gives you a flexibility basically to be able to get access to those common properties. Like cell has certain common properties, for example, like selection handlers and stuff like that. So for example, it has like all these properties for set needs, layout, content, image view. We're not going to use these, like background views, selected background views, reuse identifier, or selection style. So all these stuff your cell is gonna have access to. That's one thing. The other thing is your compiler would know that this generic type is gonna be only constrained to this type or subclasses of this, or a protocol conforming, a type conforming to the protocol that we have defined in the constraint. Now for this example we are using UI table view cell. Awesome. So that's actually good. Now we can actually change this. Instead of calling it UI table view cell for the config, we're gonna simply say it's gonna be a cell, some cell, right? And we're gonna change this to call it cell as well. Okay, and then we want to make sure that we register cell's type instead of UI table view cell. Okay, reusable identifier, we're not gonna touch that. That should be okay. Okay, so now comes to the point where we are dequeuing the cell, right? So you already know, like from your other table view creation experiences, that you have to cast your cell type, right? So what we're gonna do is we're gonna wrap this inside guardlet. So guardlet cell dequeue cell. If it cannot be performed, then we are simply going to return an empty cell. Okay, what this gives us basically is it gives us unwrapped value of cell, right? And then we can supply that basically inside our config. Okay, and that's all to it. So let's go ahead and build, and hopefully everything should work fine. Now let's go back to our view controller, and what I'm going to do is once again I'm going to copy this and comment it just for the reference, and I'm going to paste the new definition right here, and we're going to say this is going to be a generic table view. So generic table view, right? And we're gonna give our type placeholders right here. So we're gonna say that the item is gonna be of type person, and we need some sort of cell, right? So we don't have that some sort of cell. So let's go ahead and create a cell for this. So we're gonna create a person cell. So I'm gonna create a new file, and I'm gonna call this person cell. Okay, and this is gonna import UI kit. We need UI kit, so we can actually work with UI kit classes. We're gonna create final class person cell UI table view cell. Okay, and we're gonna say our person. Okay, did set. So whenever this person is set, we can unwrap that. And we're gonna say, so we're gonna create some values here, name, label, and we're only gonna show 2 items. So we're gonna show name and gender. So we're gonna have 2 labels. Okay, so let's go ahead and create those properties. So I'm gonna create private lazy var name label. We're gonna set some properties for this. So I'm gonna set the font to be v.font with size 16. All right, we're gonna create our initializer, and gonna call super.initializer with style, and reuse identifier, and here we're gonna call setup view. And we're gonna call setup constraints. Okay. All right, I was waiting for this one, so this we're gonna leave as is. And now here we're gonna add our labels into the view. So we're gonna simply put it inside a for each. So name label and gender label dot for each view, and we're gonna simply say add subview view. Okay, and then we're gonna set constraints. So name label, okay. So you have leading, trailing, and need top anchor. All right, and then we're gonna have gender label, so for the top anchor we want to constrain this to the bottom of name label, so bottom anchor with spacing 8, and for the bottom of gender label is going to be constrained to the bottom of the view with constant -8. Okay, so this is our cell, and let's go ahead and set the text for these. Whenever person is set, we're gonna set the name label. So name label.text is equal to person.name, and gender label.text is equal to person.gender. There we go. Okay, let's go ahead and try to build. Okay, so our build is failing because we did not provide the definition for cell. So here, instead of cell, we're gonna say this is gonna be a person cell. Okay, so this is basically going to be our type. All right, and here, instead of a regular table view, we're gonna say it's generic table view, and once again it's gonna take person and person cell. Okay, now we don't need this map anymore because this table view is capable of taking a type. In this case we are giving it type of person, and basically people is a collection for that, and here we are supplying person, right, and cell. So we're gonna simply say we don't need to define the cell, but we just need to set the cell dot person is equal to the person. Okay, okay, now for the selection handler, it's also gonna give us person back, person object, and we are simply going to say person dot name person dot gender. It's simply going to print that, and we're going to return the view. Okay, so let me go ahead and build that, and our build is failing somewhere. So this is where it's failing because our reload function is basically it no longer takes an array of string. It takes an array of person or people, basically. Yeah. Okay. So with that change, I guess we can try to run and see if anything changes. And as you can see, we have our custom cell showing up. It's auto resizing. So I don't know if you noticed, but when it was loading, the cell had different height, then the height changed because of all the constraints that we have placed. And this is our custom cell that's being displayed here. So as you can see, there are a lot of possibilities that are still to explore, and this makes your code highly flexible and very highly reusable. So that's why I feel generics have the power to basically make your code concise and make your code more reusable. So hopefully with all these examples that you saw in this series, basically you were able to make sense of how generics work and how you can take your specialized code and convert it into generic to make it more flexible, but only when it's needed. Okay, so that was it for this series. Thanks again for watching, and I will see you guys in another series. Thank you.